Here is an algorithm that will let us find all the prime implicants for a Boolean expression. The algorithm is called iterative consensus, and what we're doing in the algorithm is that we iteratively first expand the expression with all the consensus terms. And consensus here says that AB or A prime C equals AB or A prime C or BC. So what we do is that we take the first part of the expression and then we expand it with the consensus term of these two terms. So if we have A and A prime, then the rest of the terms will be the consensus term. And then after that we simplify this by using the absorption rule, which says that A or AB equal A. So in effect what we do is that we write a lot of terms and then we hope to find terms that have this form, and then we can just discard this term and we will remove some of the terms. And for the consensus term, it is important to understand that B and C here, they can be a set of terms. So for example, if we have x1, x2, x3, or x1 prime, x2, x4, then the consensus of this will be that we can write this as x1, x2, x3, or x1, x2, x4, and adding the consensus term here, which is x2, x3, x4. Because in our expression, this will be B, while this will be C. So here we have B and C, and since x2 is just there two times, we only have to write it one time. So let us see an example of this. So we have here our function x1 prime, x2 prime, or x1, x2 prime, x3, or x1, x2, x3. So in the first step, what we want to do is to add our consensus terms. So here we can add, so we can write this again, x1 prime, x2 prime, or x1, x2 prime, x3, or x1, x2, x3, and now we add the consensus terms. So let's start looking at the two first terms that we have here, which contains x1 prime here and x1 here, which means that the rest will be our consensus term. So here we can add the consensus, which is x2 prime, x3. If we look at the first one and the third one, there is not really a consensus term that we can write, because if we would like to use x1, which can be found as x1 in this expression and x1 prime in this expression, what we would write is x2 prime, x2, x3, but this is obviously 0 because we have both x2 prime and x2. So we can only have one variable that is a prime and not a prime in each of the expressions. So this didn't work. So can we find a consensus term of the second one and the third one? Well, yes we can, because we have here x2 prime and here we have x2. So the consensus term here will be x1, x3. And now we can start doing absorption. So if we look at the added terms, so let's start with x2 prime, x3, that we can find in this expression, so we can absorb away this term. And then we have x1, x3, which we can also find in this expression. So by absorption, we can remove this term. So what we have left now is x1 prime, x2 prime, or x2 prime, x3, or x1, x3. And if we now look at this expression, we cannot really add a consensus term, but if we look carefully, what we can see is that this term here in the middle is actually the consensus of the first and the third terms. So this we can actually write as x1 prime, x2 prime, or x1, x3. So actually already at this point here we had all the prime implicants. So all these implicants here are prime implicants. But they do not represent a minimal cover, because the minimal cover is then represented by these two prime implicants. So we have a prime cover here and we have a minimal cover here. And this minimal cover is also a prime cover. Let's take one more example just to see how useful this method can be. So we have here the function f, which is written as x2, x3 prime, x4 prime, or x1, x2, x4, or x2, x3, x4 prime, or x2 prime, x3, x4 prime. So the first thing we do is that we now want to find some consensus terms. So let us start with the first and the second term. Do we have any consensus terms here? Yes, we can find consensus terms because here we have x4 prime and here we have x4. So the rest of the terms will form our consensus terms. We can add x1, x2, x3 prime. If we now look at the first and the third term, here we can see that we have x3 prime and here we have x3. So we can add our consensus term, which is x2, x4 prime. If we look at the first and the fourth term, what we have here is that we have x2 here, x2 prime here, and we have x3 prime here and x3 here. So there are two variables which exist as prime in one and not prime in the other term, so there is no consensus term. And now let us go to the absorption step. So if we look at the fifth term, that is the first term that we added as a consensus term, this consists of three variables, so we cannot use this for absorption. On the other hand, the last one that we added, x2, x4 prime, that can be used for absorption. And what we are looking for here is another term that consists of x2 and x4 prime and some other term. So we can find here in the first one, this consists of x2, x4 prime, so this can be cancelled. Also, the third term that we have here consists of x2 and x4 prime, so this can also be cancelled due to the absorption law. So let us clean this up and write what we have so far. So we have x1, x2, x4, or x2 prime, x3, x4 prime, or x1, x2, x3 prime, or x2, x4 prime. If we now look for new consensus terms, we can look at the first one and the second one, and we can see that there are no consensus terms. We have x2, x4 in the first and x2 prime, x4 prime in the second one, so this cannot give us a consensus. If we look at the first one and the third one, we can also here not find any consensus term because there is no variable that is prime in one and not prime in the other one. However, if we look at the first and the fourth term, we see that we can now add the consensus term x1, x2. And now we can again do our absorption, which means that we can cancel the first term and we can also cancel the third term because they both contain x1, x2. And we now clean this up again, writing what we have. So we have x2 prime, x3, x4 prime, or x2, x4 prime, or x1, x2. And again, we try to add consensus terms. So look at the consensus terms for the first and the second term. Here we can see that we can add x3, x4 prime, and the consensus term for the first and the third term here will give us the consensus term x1, x3, x4 prime. And again, let us do absorption. So if we look at the fourth term here, x3, x4 prime, we see that we can cancel the first term and we can also cancel the newly added fifth term. And finally, we can write this expression as x2, x4 prime, and x1, x2, and x3, x4 prime. And there is no new consensus terms that we can add, and there is no absorption that we can do. So we are now done with our iterative consensus. And what we have found now are all our prime implicants in our expression.